So a very warm welcome to this second to last talk of this session, where I'll be talking about TestStand connecting to a bunch of different tools. But before we head off into the talk, I'd like to thank really the organizers for putting together that event, because for me, it would have been this year my first CLA summit in Budapest, which got canceled. Then my talk was accepted for the NI Week in Austin, and it got canceled. And the GDevCon in CERN was also canceled. So yeah, it really gives me the chance to present my work and to also connect and talk with the awesome people around here. So it's really much appreciated what the organizers put together. And they did really an awesome job in there. Before we head off into the talk, I'd like to introduce my moderator, with whom I can't talk, obviously, but nevertheless, thanks, Corinne, for taking this job here. Corinne and me, we both work at Silke Engineering. We are both systems engineers. I'll put that QR code up on the last slide again. So if you have questions and want to drop me a mail or want to email Corinne for whatever questions you have, then feel free to do so. You're very welcome. My name is Niko Naredi-Rainer. I'm, as I said, a systems engineer here in Silke Engineering in Switzerland. I'll take 2 minutes to talk about Silke, because I think it's also a valid place, because they give me the time to prepare this talk and also to take part in this conference, and I think that's an awesome thing. So I think they deserve it. But before we do that, I'd like to take up the hashtag that Fabiola initiated, Our Giants Are Female, to talk about women in science in the STEM areas that are not appreciated enough and still are underrepresented. I think it's a very important thing. So I chose actually Rosalind Franklin, because she got stuck in my head during studies. I studied chemistry a long time ago, and a professor, he told the story of her, because she would deserve a lot of fame, and fame passed her actually by, because she did this very well-known picture of, let me say, pointer options. She took this X-ray crystallography shot of DNA, and the so-called photo 51 that she took, 2 other scientists with the name Watson and Crick, they illegally saw this picture. It was shown to them by an assistant of her. And they came from the theory corner, and they had the theory that the DNA that you see here, so which encodes basically pretty much everything within bodies, that this is a 3-stranded helix, not a 2-stranded helix. And when they saw the symmetry of this picture, so you can also see it here, there's a 2-folded symmetry, and they immediately know that their theory was wrong. So they published in 1953, they published an article in Nature, and I quote, they said they were stimulated by a general knowledge from Rosalind Franklin. And this was obviously a big lie, because without them seeing this picture, they would have proposed the completely wrong theory. And for that article in Nature, they actually got the Nobel Prize in 1962, and none of that fame actually rubbed off on Rosalind Franklin, without whose work this would have been not possible at all. So this was really a shame how they treated her, and yeah, she was dead by that time anyway. But since it would have been allowed that she got the Nobel Prize posthume, because only since 1974 it's the rule that you can't get the Nobel Prize when you're dead. But anyways, she was already dead at that time, but it's mostly due to her that we know what the DNA looks like. So this goes out to her, and that's why I picked actually Rosalind Franklin. What do we do at Silke? To switch the topic a little bit, we are a partner for business innovation. That means you can't go into a store and buy our product directly, but what usually happens is one of our customers who are spread out all over Europe, as you see our locations, and they come to us and they say, look, we want to do this really cool project, but we lack in manpower or we lack in knowledge at some point. Could you help us out? So this is what we do all over Europe, from Manchester up here down to Sofia, and also in Hong Kong and Singapore. I have to say that in Hong Kong and Singapore, basically they're serving software customers. So they're going to banks and insurances and so on, and doing mainly front end and back end development, stuff like that, or mobile apps. Whereas we work in the systems department, which is the second department in Silke. And what we, for example, do is, for those of you who know the company of Nespresso, this coffee capsule company, Silke developed the first milk steamer for them as one of the projects. Or for those of us who like to go hiking and know Mammut, the outdoor company, Silke developed this avalanche backpack. So then when you go hiking or skiing and you get caught by an avalanche, that you stay floating on top and not be drowned by the avalanche. So this is our department and a few of the projects that that Silke has done so far. But now let's head into the talk before we lose too much time over that. I'll start off with the device under test, the DIRT. Then I'll answer the question why we need another tool, because you've seen on the first slide already that we have really a lot of tools in our tool chain at the moment, and why we need another tool yet. And then I'll go into why what is JIRA and what we use it for. And this directly leads us to the question why we need Python. I'll show a little bit of the architecture. I'll go into manufacturing data. So there I'll show some data from our TestStand. It's not the productive one, but nevertheless, I can show you some of the trial things that we have done. And in the end, I'll hop over to the caveats so that you don't fall into the same pitfalls as I do. So first of all, let me tell you about the device under test. What is the device under the test used for? It's used at shunting, for shunting at freight train stations. So basically what it is a communication device. So when you see one of these shunting train stations, you see them here. So basically you see goods that have to be loaded, unloaded, gas tanks that have to be filled, or water tank or liquid tanks that have to be filled or unfilled. And for this, these wagons have to switch tracks and go back and forth. And how that usually happens is you have a locomotive driver on one side of the train, and then you have one of the workers on the other side of the train, and they have one of communication device, and they communicate with each other. You can't use really a normal mobile phone here, because what you do is you have to follow some safety rules. And these safety rules, they are there to prevent any injuries to the workers. Let's say the worker on the other end of the train here falls off, then all surrounding trains have to shut down. So you need really to make sure that there's a standing connection in between the two and stuff like that. So this is our device under test. I will talk today about the end-of-line tester for this device under test. So for this communication device, where we had to fulfill several requirements, and that ended up in being quite a potpourri for the tools that we used. But nevertheless, so this is the basic device under test and the end-of-line tester that I will be talking about. The operating system on the device is embedded Linux with all its advantages. That means if you have a question, you can, for example, regarding the shell, you can Google that and you're getting usually a useful answer. And I talked to the device. So the device is being assembled. It is being put onto the end-of-line tester. and the PC that commands on the end-of-line tester then opens up a secure shell connection with a LabVIEW wrapper around the .NET DLL. So you can imagine, for those of you who know PuTTY, for example, for communicating via SSH, I implemented something like that in LabVIEW and then be able to communicate with the device. Why is that needed? Because the test and the functionality is already implemented on the device. So you can imagine I have something like a background light on my display and I want to make that brighter or less bright. So I send the command of the background light to the device and the test, and then tell the device to make the display brighter or less bright, and then analyze if that test has passed or failed. So this is the architecture of what the DUT is and how to communicate with that device. And you've seen a lot of tools already on the first slide. So why do we need yet another tool? So we as a company, we are responsible for the whole life cycle of this device. That means we didn't develop the first product, but we took over the development from a different company. So we were responsible for all future developments, also for the production and for the repair. Why repair? Well, you've seen this image here. So first of all, the device is constantly on the outside. So that means we are based in Switzerland. So in the winter we get snow, we get rain a lot. That means the devices are basically constantly on the outside, and also there's basically in summer there's no shadow. So the devices range from say -10 to 15 degrees Celsius to up to 40, 45 degrees. So there's a big chance that water condenses within the devices. This is hard to prevent. And also you can think of these workers, they use these devices for whatever they seem fit. So if there needs a nail to be hammered into a pallet, they use that device. We got one of the devices back, which fell into an oil tank. So you see there's also a need for repair. And to track down repair, fortunately, we at Silke have a team that is doing the advanced manufacturing services and a DevOps team that uses the Atlassian toolchain. The Atlassian toolchain consists mainly of these parts. There are some parts that are easy to explain. For example, Bitbucket. Bitbucket is just, you guys know GitLab or GitHub, and Bitbucket is just the implementation from the Atlassian toolchain. So this is what we used during our development, where our code repo was stored, where everything that code related was in there. Confluence is like a wiki. So it's a team wiki where the focus is on knowledge sharing and efficient knowledge transfer. And this is really used for together with Bitbucket, for example, so you can document which version fixes, for example, which bug, or which pull request really was used when and where and who approved, for example. So this is for documentation. And then there are three parts to JIRA. This is JIRA Core, JIRA Software, and JIRA Service Desk. We didn't use JIRA Core. JIRA Core is more for, like, let's say, a marketing team that has a certain workflow. This may be a simple to-do list, like things that need to be done, things are in progress, and things that are already done. Or it can be a 7-step automation or a 7-step workflow that is heavily automated with, for example, website building and stuff like that. So this is JIRA Core. JIRA Core, Software, and Service Desk, they all rely on a certain workflow. For example, JIRA Software adds then for software teams the ability to put Kanban boards in there, to follow an agile software approach. So during our development, we followed partially agile software approach, which we call Scrum for systems, because with hardware it's not always so easy to follow everything that you usually do in this like in software like you do. So basically this is Kanban boards and stuff like that. And then you have the JIRA service desk. Imagine you have your computer does not do what it should at the moment. Let's say the graphic card is not working as expected. So you call your IT center, and this creates a ticket for the IT center, and they take your laptop and then repair it and give it back to you. So JIRA Service Desk does that basically for you. So it gives the customer the opportunity to open a ticket, link that ticket to some piece of hardware, and then follow the ticket through its life cycle. Let's say you send the device in, it's being repaired and it's being sent back. So this is what we used JIRA Service Desk for. Also, to be fair, you have to mention that JIRA Service Desk needs additional licensing, just so that you know. So all the other ones, they go under one license, I think, but the JIRA Service Desk, then there you really need each client that has one of these licenses to have a license for them. So JIRA, as an overview, you can really track bugs, change requests from a software side. You can do project management. What is really also interesting, you can also do requirements management when you start off with a customer. That is also really, really interesting. Each of them has a workflow, and what we used is the service portal as a customer service. So you can basically type in your problem, and if you don't find a solution for that, you get the ability to open a ticket and create the ticket on the issue that you have. And this is why we used JIRA as a service desk. And we the question is still the connection between the end-of-line tester and actually the JIRA. So why does my end-of-line tester need to talk to our service portal? So I use TestStand as my framework for that, and the processes are so the repair process and the assembly process, they take place in the same site. So assembly and repair process are under one roof, more or less, but are two separate processes. So let's say we start off with an assembly. So the parts are the device under test is being assembled, and once it is done, it goes into the end-of-line tester. So this is actually basically the core of it. This is my TestStand code that calls LabVIEW, that speaks with the device under test. Let's say my device does not pass all of the tests, so the device has to undergo like 47 tests approximately. And what let's say it doesn't pass the brightness test, so the display can't be the display brightness can't be passed. So you take it out, you repair the display and probably the PCB below it, and then it goes back into the end-of-line testing and you pass. And if it's an assembly, you print the label for it, and you upload your data to WATS. I will talk towards the end of the talk. I will talk about WATS and show you a demo of what you can do there. And it will create a JIRA component. That means it registers the serial number that we just assembled with our JIRA instance. Why is that useful? We simply have our ticketing system, and each ticket has to be connected to a certain serial number, so that we know, okay, this ticket we get the device shipped in belongs to this device under test, and we can go ahead and repair it. And then the second line that you process is more or less a reuse process of that end-of-line testing, because if we repair or if we assemble the device, each device has to undergo the end-of-line testing to see that it's fully functional before it goes out. So let's say a customer opens a ticket, gets the shipping label to be sent back to the repair center, and then the shipping department of our repair center checks whether there is a ticket with that serial in JIRA? If yes, then it goes ahead. If no, the repair center manager and we are notified that there's something not in order, and we can clear it up. But if we find that ticket in JIRA, we start the repair, again goes through the end-of-line tester, it passes. It's this time a repair, and then we tell JIRA, okay, the end-of-line tester has passed fine, and we ship the device, and the device is being sent out. How does that translate to the JIRA workflow? So a ticket in JIRA can be in different states. It can be open when the customer simply just opened the ticket. Can be acknowledged when, for example, the device is already in-house. And from acknowledged, we can, for example, see, well, a train rolled over our device. I see there's a question. Let me shortly finish, and then I'll sum it up. So we see, for example, a train has rolled over the device and it's not repairable anymore, so it goes to the don't fix state. Or we can say, okay, well, let's repair it. It's in progress. It has passed the end-of-line tester. I'm ready to release, and then we ship it. The thing is, in JIRA, you can't. So these all are objects in JIRA, and in JIRA, you can't really change the state, but you have to execute a transition method. And this transition method then kicks, for example, from an open to an acknowledged state by accepting it. And this transition I can kick off in TestStand. And then again, for example, this transition would be start repair, or this transition here would be not repairable. So these transitions I can kick off as methods on my ticket. So Kare asked the question, why not testing the DUT before you repair to be sure that the DUT is defect? So I'll show some examples, or I'd already talked about some examples. And these devices, then when they go in, you usually see what is faulty. So mainly you see broken displays, or you see that there's a crack in one of the buttons, for example. So you really see usually what's going on. It's less often a software failure, and since the end-of-line tester displays what the customer has written, you can, for example, really check it. So these devices are also usually, when they are, they can be updated remotely. And when one of that update fails, you simply have to power up the device to see that the error message that the customer sent in is actually also the error message that you see on the device. So mainly it's hardware faults due to wrong handling of the device, or simply circumstances. But if there's a software updating error, for example, then you also would see that. So usually you don't have to go through the loop before you test it. I hope that answers this question. Perfect. So to take a look at it in a more familiar way, so some of us that do Agile projects, they are used to Kanban boards. So basically what you see here is tickets, an overview of tickets. So if a customer opens the tickets, it's in the open state, then the shipping department gets that device and puts the ticket into the stages that the device is where it should be. So we have it there for repair. And then the end-of-line tester can do these transitions. So it can say, well, the device is being repaired, or it has passed the test, or it won't be repaired anymore. And once that is done, let's say our device has passed, the shipping department takes the device, sends it off, and in the end, the customer then takes the device and closes the ticket, or takes the ticket, sorry, and closes the ticket, so that you know that the whole transition is done. So why then? Okay, now we have explained why we need JIRA. We need the ticketing system. TestStand anyway, because it's the end-of-line testing. LabVIEW to talk to that. Okay, so why then throw in another tool of Python? The thing is, the de facto standard for request response at the moment is the REST API. And this JIRA instance we have it on site. Really, it's an on-premise instance, so we need the end-of-line tester and the assembly and repair center to talk to our JIRA instance. So the cool advantage with the REST API is that you don't need an additional port except what you do for internet communication. So whether you're doing a get, post, put, or delete towards Google or towards our database, that basically doesn't matter. You get a response back, which is usually, in our case, JSON, and that you translate back to it whatever answer you need. So that's what you need the REST API for. In my experience, what I did first, okay, I Googled for LabVIEW REST client and had it off there. Why LabVIEW REST client? LabVIEW is my native programming language. That is where I think my greatest strength in programming is. So I tried that. That worked actually fine for basic authentication. So that meaning if you see here on the left, my end of line tester, and here our JIRA instance. And as long as the JIRA was doing basic authentication with username and password, this worked fine. But then our DevOps team switched JIRA to OAuth 2, which is a different way of authorization. And this was then all of a sudden not so easy anymore with LabVIEW, because what you have to do with OAuth is do a little OAuth dance. That means, first of all, our end-of-line tester here, they request authorization with the JIRA server. And then a DevOps engineer has to go in via the browser and say, well, I know this PC, I know this token, and I can guarantee that this is the correct application. I authorize this application, and then you get, as a client, you get the authorization code granted, can do a token request and get the access token grant. You get that back. And so the first thing that I did was, okay, again, went to Google and say, look, do I have an OAuth toolkit for LabVIEW? And indeed, there is one. You can do OAuth with it, but as you can see here, it will not help with the OAuth 2.0 pattern. And I see another question, and I'll answer that in a minute. So I say as well, you might find bits and pieces useful in this scenario. So I went in there and did a little try, but honestly, I was not that experienced with the REST API, and I was not experienced with the OAuth toolkit at all. So pretty much really every node in there threw an error. And so I went back to our DevOps team and asked, hey guys, what are you using to talk to JIRA from the outside world? And they said, yeah, standard is basically Java. And I said, well, Java is not really my strength. So is there any alternative to that? And said, well, nearly as good and as often used as the Python code. And they gave me just a bunch of Python lines and lines, and I told myself, well, it can't be so hard. So let's jump into looking at the whole project with Python, because basically all what you need to do is you have your secret, your access token, which is being read in here, and then you do one line of code, and instead of a whole bunch of things that I didn't understand at that point of time, and you're in there. So I hope this answers the question with Python. And so I really did use Python in the end. What I did as a middle layer, I tried the REST API commands with Insomnia. So for everybody who gets started with the REST API, I can really recommend to use Insomnia, because you get useful debugging information back, what fails and what does not fail. So as a middle layer, this is really interesting and was really helpful for me. So this is what I ended up using. So I ended up the Python JIRA REST library, and there's also the comment in the chat that 2019 has a Python adapter, and this is true, and this is what I ended up using. So because what you need, you import the JIRA library, and the JIRA library completely abstracts the REST API and the REST commands behind it. So basically, all you really need to do is like do a 1-line or 2-line commands from Python, which is really helpful. So to show you my overall architecture, it's basically a LabVIEW GUI calling TestStand 19. So this is the whole computer that you see here. So the LabVIEW GUI would call into the TestStand engine. This will again call a LabVIEW adapter and talk to my device on the test via SSH. So and the nice thing, I think before TestStand 19, they were the Python custom step types. But since 19, it's natively in there. So I use this Python adapter to talk to the Atlassian JIRA toolchain. So this is where then I kicked off the transitions for my tickets. And additionally, I used the .NET adapter because a colleague of ours, he programmed an easy result handler where you could upload all your production data onto a WATS database. So this is also really interesting because the WATS database gives you insight into the data that are being thrown out by the production. And before, I'll show a little demo of WATS and how some of the data could look like. So WATS has been produced by guys that mainly come off, that have an NI background. So TestStand and LabVIEW are really natively supported. For TestStand, there's even a plugin, a reporting plugin, so that all of the reports that you're generating, you can basically upload by simply one click and entering your username and password into your WATS instance. So this is really helpful in there. And WATS helps you basically gain insight from your production data so that you can democratize your data, which is really important. For example, if you have different sites where you're testing, so you see that there might be production sites here, and wherever you are over the world, and you need to collect these data. We had only one production and repair site, so this made things easier, but nevertheless, you can take a look into your production data. So let's take a look into WATS. I'll pick it up here. So I hope this works. Yes, looking good. So this is my this is now not productive data, but data that we generated for showing off purposes. And you can log in as different users, saying, I want to be analyzer, I just want to be operator, and take a look at today's throughput, for example. And as admin, of course, you got all the rights for the whole instance. And if you don't go to reporting and look in our dashboard preview, you see, for example, here an overall graphic coming up, so that you can see, for example, look at the time that I selected. I have 331 test reports. I have a test yield of 88.22%, which is not the best, but I'll show you how we improve that over time. And which is also cool, and a nice thing, you see immediately which test fails most often. So the test, our device has phone capabilities, and this is the test that actually fails most often. But to explain that a little bit, it's rather easy. The assembly line is in the basement, and if the modem, if it's turned on for the first time, doesn't find reception immediately, that test fails. But you see that also the battery flow on the battery. The current flow on the battery gave some troubles, and so on. You immediately see where your process can be improved on that point. And if you go down, you see that there are a bunch of reports, how many passed, how many failed. You immediately see you can go into each report immediately, but you can also pick something up like the yield report. And you see that we have two different part numbers that are being produced here. And the first one, it has a first pass yield of 89.55, and the second one, the second generation of our device, has a first pass yield of 98.88. So this is where we would like to be. So we could improve our processes, and you immediately see that, which is really cool. And if you go back once more and take a look into, let's see if that has loaded, very good. And take a look into each test report, you see that this looks like a more or less like a TestStand report. And if you now, for example, go into system check, you see that it has a temperature monitoring chip on there, and you see that this measurement is 27 degrees. And if we now go to the graphs, this is also what's really cool. You see that it takes all the measurements, it loads them, and you really see of all the devices that have been tested so far, you see up there that most of them have passed. Only a couple have failed. You can really go into that. But you can also see, for example, that there's 2 temperature distributions. So it seems to be hotter during summer, and then the rest is obviously with the AC control a little bit better, but this seems to be a hot period. And you see the low limit and the high limit, which is between 10 and 40 degrees Celsius. And if you now click on one of the failed that are outside, it immediately takes you there to that measurement, and see that the measurement here is 0. So that you can see, well, and that device in the test, the temperature sensor seems to be broken in here. You might ask now why we here did our own result handler and not use simply the report plugin from WATS. And the reason is quite simple. It's simply money. I see a question popping up. I'll talk about that in a minute. The thing is, when you're using sorry, I got confused a little bit here. When you're using the reporting tool that WATS itself offers, you're throwing every bit of data that you get in a TestStand report, like every if statement, every for loop you're throwing on there. And the pricing model from WATS is the less data you put in there, the less money you pay. So this is like with every cloud service, the less data you put in there, and the more specific you are with what you want to have analyzed, the cheaper it gets. So this was for monetary reasons, that we are not having a top-down approach where we throw everything in there and then delete what we don't want, but we specifically upload what we want. And Ernesto asks if we considered System Link, the test module, in place of WATS, and we did that. The reason mainly why we chose WATS was at that point, System Link was not, so the dashboard was not really what it is now. So System Link has evolved from when we evaluated it. At that point of view, WATS was still a little bit in the lead when it came to the dashboard and to capabilities of immediate analysis of your result data. I hope, Ernesto, that answers your questions. Very cool. So let's take a look. So for the time, we're still fine. Let's jump into the caveats from Python and TestStand. So as I said before, I used TestStand with the Python adapter. And you have to make sure that you have the same bitness for both. Well, this makes it pretty clear. So Python 3.6 and in 32-bit, and TestStand also in 32-bit, and LabVIEW in 32-bit. Seemed very clear to me, and no problem for that. But what I did on the production machine, just to look into my Python scripts, I had Notepad++ installed with a connection to the Python engine, so that I could run my scripts from Notepad++. And then in the Python adapter configuration in TestStand, I entered not Notepad++, the Windows Notepad as standard editor when you want to view your Python scripts, but I actually entered Notepad++ in there. And Notepad++ was a 64-bit application, and that led to really nasty crashes from TestStand with a very generic error and no clue where that came from. So although in my eye, when I did that, it really had no connection but opening a different program to open up the the editor for a text file, that really crashed my TestStand instances an awful lot, and it took me quite some time to figure it out. Also, when you're returning results from Python to TestStand, Python doesn't declare, necessarily broadcasts what they are. So TestStand doesn't know if it's a string, if it's a Boolean, if it's a number. So what it does, it labels them as dynamic. And dynamic data types, they often lead to crashes when you execute the TestStand sequence. So be sure that when you're returning values from your Python instance, that you label them correctly. And if you're having complex data, like let's say a dictionary, for example, that you keep them in Python and hand only back the object reference, and then in the next step where you want to further analyze your result, then use the object reference again and hand it over to Python, and you can hand off from there. What is also really interesting behavior is that the current working directory for Python is not identical depending on where you start your Python context. That means when you're in the sequence editor, and you're calling CVD, so you want to know where you are in Python, it will give you the working directory where your sequence is actually saved. If you're calling now your LabVIEW GUI, which then calls in the TestStand engine from LabVIEW IDE, it will give you actually where the main VI is being saved. Whereas when you compile it as an exe, it will give you the place where the exe is saved. So for me, that was important because I loaded in Python a file from disk, and I did that relative to where the file, the sequence file was stored. And that in the compiled version or even in the GUI, that led to a lot of crashes because it didn't find, not crashes, but errors, because it didn't find the file that I was looking for. So be aware of what you do there. I also looked into the Python node from LabVIEW, and I was developing with LabVIEW 2018, and it was not possible, or I had a lot of problems calling my Python code from the packed project libraries, because when we work with TestStand and LabVIEW, we usually pack our libraries. Not easy to do when we did it from LabVIEW and Python in the packed project libraries. But this might have changed. I don't know about 2019 and 2020, so this might be different. And as a goodie, one of the things that I didn't know, and which is not so much propagated in packed project libraries, the runtime engine equals true, evaluates always as false, no matter if it's actually true or false. So this was one of the goodies that I didn't know of. So perhaps you avoid this mistake that cost a little bit of time from my side. So to summarize things here, I used the Atlassian toolchains during development and during operation, and that was rather successful. So the customer has really a portal with frequently asked questions, with sort of a small wiki, and if it doesn't answer his questions, he immediately gets forwarded to open a ticket and then send in the device. So that was really helpful. JIRA was used for task tracking during development in an agile manner, and later on used as service desk. So I hope you guys are not sticking to my title where TestStand goes agile, but it's really the connection of agile toolchain with LabVIEW and the NI world of TestStand. The REST API, I think there's no way around the REST API for request response communication as de facto standard in the web. Once you get to know your way around, it's also rather straightforward. But I highly recommend, if you're not really proficient with the REST API, to take a look into Insomnia, because it will give you a lot of starting points and a lot of help in debugging. So REST and Python, so web technology and Python, they go actually hand in hand. and it really offers a lot of value through the existing library. So when you have already an abstraction layer that takes off all the low-level REST communication and hands you off one level of code, I think it's better and easier to learn a little bit of Python, and instead of trying to use LabVIEW and force it onto something that it's probably not natively supposed to do. So, I mean, you can do it, and I saw a couple of blog posts out there for OAuth 2, but I never managed to get it working. And with Python, it took me like, I don't know, 2 days, and it was there, compared to in LabVIEW where I didn't really know where to start. So, as I said, this has potential, but at the time of development, when we developed that project, we had a bunch of problems with it. And so in the end, we used a lot of tools. I mean, we used TestStand, we used LabVIEW, we used Python, we used JIRA, Bitbucket, and so on. So, and I think they're all helpful. You can, when you know what each tool does, you can put it to work correctly. But I think a big problem is really knowing by now which tool is best suited for what. And there you have to choose really carefully in the beginning. But when you know how it's being done, then you can really set it to work most efficiently. And with that, I'd like to finish up. I'd like to thank you for your attention. If you have questions, feel free to put them now into the chat, or you can also email me directly with that QR code, or I'll be around for the next hour. Chat me up. That is absolutely fine. I'm looking forward to your questions. And if you need any advice on how to approach that topics, may it be with a customer, may it be for your own internal reasons, feel free to talk to us. We're happy to help. So thanks a lot for your attention. So let me monitor that chat for a bit. So for Kare popping up the question, I can show you basically that slide again. I hope you see it. So basically what the test station does, the end-of-line tester, is it, so you can't manually take the ticket and put it from device within repair center to device under repair or device has passed end-of-line testing. So this is configured to be only to be done via REST API, so that none of the guys in the repair center can simply take the ticket, put it into device has passed, and then send it out as broken again. So really, the end-of-line tester and the test station, they have to transfer this ticket to device has passed. This is the main reason. We are regarding Martin's question, using the repair report feature in WATS. We have started using that, and that is really awesome because you can get out a repair report. So WATS, to make it more general, step one, and to go one step back. WATS also has not only assembly report, but also repair report. And this functionality is really cool because when a device gets in and it already knows the serial number, you can actually get an overview of what has been done with the device. So you can start giving out a repair report with WATS and prove to the customer that all the functionality that it has been tested. So yes, Martin, we started using that. Thanks for that hint. I think that's about it with the questions in here. Okay, then we're perfectly done with 10 minutes to go. And for, I think, Piotr to take over. I'll head over to the breakout room. So if you need to know anything or keep on chatting, I'll be in the breakout room. Thanks a lot, Corinne, for sending me that advice. So our communication was really awesome. We used a mixture of Teams, WhatsApp. So thanks again, Corinne, for jumping in here. And thank you guys for listening, and meet you in the breakout room.